Hey guys, I'm Joshua. I'm part of the Unicity team, and I am going to talk about a little bit about what I'm working on right now to get where we currently are with the proof of work transactions, a lot like you would find on Bitcoin today. And we're working towards a system which essentially is getting us to a state where we are not on the proof of work blockchain, and there is a mechanism where you can redeem the coins from that chain onto our ZK EVM, which is a big step. Okay, so today we have proof of work, and of course you have your transactions underneath here, you have your blocks underneath, you have your blocks here, and most importantly, these blocks are validated by our lovely miners, including Mike's miners himself, and and we have a challenge of being able to get these transactions off, and so that we can use them within Unicity. So we have proof of work. We have our BFT consensus protocol here, which guarantees us fast times to finality. From proof of work, you have something called scripts. And scripts are essentially, were originally designed by Satoshi himself, and they provide essentially a puzzle for someone to prove that they own a transaction in the proof of work blockchain. And we call them by two names. So we got a locking script, and we also have an unlock script. So every single time that you send a transaction to somebody, it's going to be providing a locking script. And that locking script is needs to have an unlock script to be able to unlock that transaction. And at that point, you can spend that transaction. It's essentially your proof that you have the ability to send this money. We are working in a ZK or zero knowledge environment, and I am developing a ZK EVM, which essentially will have special abilities where it will be able to get from proof of work the block headers, where it will be able to verify the chain state just like any other node within the network. So this will exist within the peer-to-peer network itself. It'll be able to pull in information. It'll be able to verify and validate the proof of work blocks, the headers, the transactions, all of it. And it will then go to a special EVM contract that we call precompiles. And a precompile is essentially a pre-compiled smart contract which has access to information and also state, like a database, which other regular transactions wouldn't be able to have. So in this precompile, the cool thing is that we can feed these blocks and block headers into the precompile, and the precompile can then run the mechanism to verify that the blocks are correct. And in this way, we essentially start building up a set of transactions which can be claimed by somebody within the ZK EVM world. Now, there's going to come a time where the proof of work as we know it today, or the chain as we know it today, is going to go through a reset. So the reset is going to start back, roll over, and we're going to take the latest set or the last set of those transactions, which people can verify, and bring them into the ZK EVM as a sort of genesis to kick everything off. Now, these are not by default just given out to addresses. These need to be claimed. In this, we get an unspent transaction output set, which will have all of the transactions that have not yet been spent up until that point. And someone will be able to access a special function within the precompile called redeem. And the cool thing is that going back to scripts and how they work, these unspent transactions are going to all have this locking script. So all someone would need to do is to provide this unlock script. And optionally, where are these tokens going? So a target. And when this is called, it will make a transaction on the EVM. It'll verify that this person that is providing the unlock script actually is the owner of one of these transactions, and it will run against it, and if it is true and the unlock with the provided lock script are successful, it will remove it from that UTXO set and output to whatever address that may be. Now, what about going forward? Because we still are going to have miners mining proof of work. They still need to verify that they do, that they have mined this block. They still need to be able to be part of this system. So, additionally, we can, or we will have another data set which would essentially have the block headers, or the blocks themselves, which are not yet cleaned. And from here, people can do the same thing. So in this case, instead of just redeem, we can say redeem block. And with redeem block, all they would need to do is essentially prove through signing with their private keys that they're the ones that actually did sign off on that block to submit it to the network, which was accepted. And through providing that signature, and including what block that was, rather by hash or by height, and given that it has matured, so right now on Unicity it's 100 blocks for maturation. Provided that this block is 100 blocks old, and this person is proving that they do own it, or that they did sign off on it, it will essentially list this as redeemed, and again, we will get the value that needs to be sent to whatever address that needs to go to. So that's essentially like our very basic example of essentially how this will work. And of course, with our EVM, the neat little thing is that we can get contracts running on here already, and we can also get this working in an environment that prepares us for our big jump into the greater Unicity platform. That's it. All right, thank you.